In this video, we're going to be discussing the last four trigonometric graphs and what they look like. So let's first discuss the tangent graph. What we have here is the tangent graph, and when we talked earlier in the last section, we talked about the domain of tangent, and we said that there were certain places where the tangent would not exist. And if you remember, those were at all of those pi over 2's. We called them every k pi over 2, where k was an odd integer. And what you'll notice here is that I have vertical asymptotes at those places where tangent doesn't exist. And it would occur at pi over 2 and 3 pi over 2 and 5 pi over 2, and then on the negative end, negative pi over 2, and so on and so forth. What you'll also see smack dab in the middle of those vertical asymptotes, you'll see that the graph of tangent actually crosses over the x-axis. And those would be at all your values of pi. And the last thing you want to notice is that the graph always rises through from left to right. And it starts over again by rising from left to right. Now the period of pi is a little different, the period of tangent is a little different than the period of sine and cosine. Remember, we said that one complete cycle of sine and cosine is completed in a distance of 2 pi, but what you'll see for tangent is that the period is actually just pi. And we've said that those vertical asymptotes are at k pi over 2, where k is an odd integer. So that's the graph of tangent. So let's move on to the graph of cosecant. And what we're going to do to find the graph of cosecant, we're going to graph sine, who is cosecant's buddy. Okay, so I have just a dotted line for sine as a guide. And we know that sine and cosecant are related by their ratios because they are reciprocals of one another. So wherever sine equals 0, in all of these places where it crosses the x-axis, where it equals 0, that's going to be the places where cosecant is actually undefined. And what happens in between those places? Well, it's actually very simple. Let's just look and see what the graph of cosecant looks like when we have sine graphed with it. Wherever there is a vertical asymptote in between those places, you'll just put a little bit of, we have our vertical asymptotes, and then it just has all your loop-de-loos. And they touch at these places at 1 and -1. But we use sine as just a guide to graph cosecant. So now later on when we're asked to graph a cosecant function with lots of different numbers going on in there, we're just going to graph the sine function that has those same values and then put our vertical asymptotes in and our loop-de-loos, and we've already graphed cosecant. Let's talk right now about the period of cosecant. Notice that one complete cycle is an entire valley as well as mountain, and so that is a distance of 2 pi. And we also have vertical asymptotes, and it looks like all of those asymptotes are at all the values of pi, and so we're going to say at k pi, where k is an integer. Alright, a little messy, isn't it? So let's discuss now the graph of secant. Well, you know what's really awesome about secant? His buddy cosine is going to help us graph him. So I now have a dotted cosine graph. Notice that cosine starts at the top. And continues down and then ends again up at the top. So there's our cosine graph. And again, where cosecant where cosine equals 0, those are going to be the places where we have vertical asymptotes, because those are the places where secant would be undefined. And let's look and see what happens when we put our secant graph in there. You see we do have our vertical asymptotes. And we have all of our loop-de-loos in there. Again, your loop-de-loos actually touch the cosine graph, but they just flip. Okay, and so that's secant, and the period of secant again is one complete cycle, and you can see that one cycle does continue all the way to 2 pi from back where I start up again. And now I would start over. So my period is 2 pi. And where does it look like those vertical asymptotes come into play? Well, again, they look like they're happening at all of those k pi over 2's. So our vertical asymptote is at every k pi over 2, where k is an odd integer. Okay. So, the last graph we have to discuss is cotangent. And obviously cotangent and tangent will have some commonalities. So let's put the tangent graph on there. And the cotangent graph, I'm going to go ahead and put it on there, and it's going to be in blue. But what you notice here is that the cotangent actually decreases from left to right, and the vertical asymptotes are at different spots. And you will also notice that the cotangent's period is as well pi, just like tangent's period was. Let's take the tangent graph off. So we have our vertical asymptotes running down through here, and it looks like those vertical asymptotes are occurring at every pi value. We've already said that our period is 2 pi. Vertical asymptotes occur at all of our k pi, where k is any integer. And again, smack dab in the middle of these asymptotes, it crosses over the x-axis and then it falls down through those individual sections between the asymptotes. So let's work together here and do one example of a more complex cosecant graph. What I have here, t of x is 3 cosecant of 2 times the quantity x minus pi over 4. And what we would like to do is come up with the correlating sine function. So we're going to actually graph 3 sine of 2 times the quantity x minus pi over 4, because that's going to be the function that helps us graph cosecant. So let's find all of these values. Amplitude, we would say here is 3, and the period is going to be 2 pi over 2 excuse me, which is going to reduce to pi. And what we also have here is a phase shift of pi over 4, and that will be moving to the right pi over 4 units because it's a minus. So let's graph this function. It's a sine function, so it starts in the middle. And so I'm going to actually start pi over 4 units to the right, and so my first dot is going to occur there. And we also know that the period is pi units, so I'm going to have to end my graph here. And my amplitude is 3. Notice that my y-axis scale is going by 2s, so my graph is going to go up to 3, come back down in the middle, and then down to -3. And so here is my sine curve. That's only going to be a guide. And what we want to do now is use that sine curve to graph one period of cosecant. So remember, with cosecant, everywhere where sine equals 0, we're going to put our vertical asymptotes down through. Okay, and let's get a different color here. We'll use green since it's kind of Christmas time. Alright, and now what we're going to do is put in our loop-de-loos for the cosecant graph. So cosecant will follow along like that. And it would continue on forever and ever in either direction, so we could continue our sine and cosine graphs. So I know we can't completely check our answer because I had to clear it out, but when we do click on the graph, you can see that we have the loops occurring where we said, and they extended the graph on forever and ever. So come back to class tomorrow with a better understanding of the other 4 graphs. We'll do some more examples in class, and see you tomorrow. Bye everybody.